Irodov problem number 1.130 on the board. A body of mass m is hauled from the Earth's surface by applying a force F varying with the height of ascent y as F equals 2 times Ay minus 1 times mg, where A is a positive constant. Find the work performed by this force and the increment of the body's potential energy in the gravitational field of the Earth over the first half of the ascent. So, for this problem, the force F is given as 2 Ay minus 1 times mg. Okay. Obviously, there is another force that is acting on it, which is gravity. Let us say Fg is mg. Okay. Now, before we rush into drawing the free body diagram, let us just analyze this force a little bit. At y equals 0, this force at y equals 0, this force is minus 2 mg. Okay. And obviously, force of gravity is always plus mg in the downward direction. Now, if a body is said to be hauled up, so if mg is always acting downward, this force of gravity, this force to act up, it has to act upward to haul the body up, otherwise it's never going to rise. So, this 2 mg initially is on the upward side, okay. But since this evaluates to minus, which means the force F will have to take the direction to be in the negative direction, okay. So that at y equals 0, this turns out to be negative of 2 mg, so it will be in the positive direction. So, that is the reason it will start to climb up. As y increases, this force will slowly become less, and at some point this force of gravity will become more than that, and that will be our highest point of ascent, okay. And then the body will start to come down, okay. So, the wording of the problem is such that you have to realize that the direction of this force is downward, but it evaluates to minus 2 mg. So, at y equals 0, it is positive. So, just be a little careful with that, and then we can denote the acceleration as w in the upward direction, okay. So, if we have resolved that using Newton's law, what we can write now is mg plus F is equal to minus mw, okay. So, we can write mg plus, we substitute the value of F, 2 Ay minus 1 times mg equals minus mw, okay. Let us now resolve this. So, m's we can cancel, g plus 2 Ayg minus 2g is equal to minus w, or w we can write as 2g minus g is g minus 2 Ayg, if we take g common, 1 minus 2 Ay, okay. So, we got the acceleration w with which the body is moving up initially, and then once it reaches the highest point, it will start to come down. Now, what is the condition when it reaches the highest point? The velocity will be 0. After that, the velocity direction will flip, it will start to move down. So let's look at this W. So W we can write as dV dt. We can also write that as dV dy dt. Now dy dt is V, so we can write this as V dV dy. Okay. Now let's bring this dy on the other side, so W dy. Now W we know as a function of y is g 1 minus 2ay dy v dv. Okay. Now let us integrate both sides. Okay. When y is 0, velocity is 0, and let's say at some y, velocity is v. Okay. So this becomes v square by 2 is equal to gy minus 2agy square by 2, 2 gets cancelled, or gy minus agy square. This is v square by 2. Okay. Now let's substitute v equals 0. So that gives us agy square minus gy should be equals to 0. Gg we can cancel. So ay minus 1 should be equals 0. So there are two solutions here, y equals 0 and the other solution is y equals 1 by a, which makes sense. So at y equals 0, also velocity was 0, it started ascending, and at y equals 1 by a, it stopped and then it flipped direction. Okay. Now we got the maximum point. So the first half of ascent is from y equals 0 to y equals 1 by 2a. Okay. Now we are required to find out the work done by this force F during the first half of ascent. So that's simple as y dy, and range of y is from 0 to 1 by 2a. So which is F is 2ay minus 1 mg dy 0 to 1 by 2a. We can take 2 mg outside, it's a constant, and this evaluates to ay square by 2 minus y. The range is from 0 to 1 by 2a. So let's substitute 1 by 2a for y. So a y square, so a by 2, let's say, y square is 1 by 4a square minus 1 by 2a. So this is 2 mg, a gets cancelled, 1 by 8a minus 1 by 2a. We can write this as 8a, 1 minus 4, 2, and this is 4. So minus 3 mg by 4a. So this is the work done by the force F during the first half of the ascent, minus 3 mg by 4a. Okay. One thing I should have done is, now the direction of F is in the downward direction based on this, and the ascent was in the positive direction, so this should have been negative. So we should have done minus f dy. So basically this we should actually correct it as work done by the force F is positive 3 mg by 4a, not negative, okay. So just a matter of convention, but it's important. Okay. The last part of the question is, what is the change in potential energy due to gravity? Now potential energy due to gravity is given by mgh, where h is the difference in height from the ground level to the height attained. In the first half of the ascent, the height is 1 by 2a. So we can simply write this as mg by 2a. Okay, so that is the gain in potential energy. All right, so that's our solution.